Have you ever just looked at a few lines of code and wondered, how on earth does that tell a machine what to do? Well, today, we're going to pull back the curtain on all that. We're going to demystify the basic building blocks of programming using one of the most popular languages out there, Python. So get ready. We're going to go from simple little bits of data all the way to giving a computer some pretty intelligent direction.
It really all boils down to this one simple question. At its core, programming is just that, right? It's giving a computer a set of instructions that it can actually understand. And you can think of Python as the language we're going to use to have that conversation.
You know, every single program you've ever used, from a tiny calculator app to some massive AI, it all starts with the same raw materials, the ingredients. And in the world of programming, our number one ingredient is data.
Okay, so how do we even begin to handle that data? Well, we use something called variables. And honestly, the best way to think about a variable is just as a labeled box. That's it. You give the box a name, say user age, and then you pop a piece of information inside it, like the number 30. And just like that, your program can find and use that information anytime it needs to just by calling the box's name. Simple.
That's the logical next question, isn't it? A box is great and all, but what can we actually put inside it? Because for a program to work correctly, it has to be super specific about the kind of information it's storing.
And that, my friends, brings us to data types. This is just a fancy way of saying how Python categorizes information. Think of it this way. You wouldn't use a screwdriver on a nail, right? You'd use a hammer. In the exact same way, Python needs to know the data type so it can use the right tools on it. Let's take a look at the most common ones.
Okay, I know at a glance this might look like a bunch of jargon, but trust me, it's incredibly simple. An int, that's just a whole number. A str, or string, that's any kind of text. You just wrap it in quotes. A bool, that's short for Boolean, is your basic, straightforward true or false. And then we've got these collections, lists and tuples. They're both just ordered collections of items, but they have one very crucial difference. And this is the key difference right here. Lists are what we call mutable. Think of a shopping list that you write in square brackets. You can add things, cross things off. It can change. Tuples, on the other hand, are immutable. Once you create one, its contents are locked in. Think of it like a fixed set of coordinates that you'd put in parentheses. So you use lists for things that are going to change, and you use tuples for data that you absolutely need to protect.
All right, so we've got our ingredients, right? They're stored, they're categorized, but, data just sitting there is, well, it's pretty boring. It's time to start taking some action.
So yeah, we have all this information sitting around in our nicely labeled boxes. But how do we get it to interact? How do we calculate things, or compare things, or manipulate it? Well, to do any of that, we're going to need a toolkit.
And that toolkit is made up of these things called operators. You can think of them as the action words or the verbs of Python. Arithmetic operators are just your basic math symbols. Relational operators are for asking questions like, hey, is this value equal to that one? And they always give you back a true or false. Logical operators let us combine those questions, and the most basic one of all, the assignment operator, is just that simple equal sign we use to put data into a variable in the first place.
Okay, now we are getting to the really exciting part. This is the moment where a program stops being just a simple to-do list and actually starts to get smart. It's time to make some decisions.
The big idea that makes this all possible is called control flow. See, normally a program just runs from the first line of code straight down to the last. Control flow lets us mess with that order. We can tell the program to skip lines, or to choose between different paths, or even to repeat a set of actions over and over again.
And the most fundamental decision maker we have is the if-else statement. Just think of it as a fork in the road for your code. The program checks if some condition is true. If it is, bam, it goes down one path. If it's not, it can then check an elif, which is just short for else if, condition. And if none of those other conditions are met, it'll take the final else path. This is exactly how your program can react differently to different situations.
Now, the other side of the control flow coin is repetition. I mean, nobody wants to write the same line of code 100 times, right? That's where loops come in. A for loop is perfect when you want to go through each item in a list one by one, and a while loop just keeps on running as long as a certain condition stays true. It's all about making the computer do the boring, repetitive work for us.
So as our programs get more complicated, with more data and more decisions flying around, things can get messy, fast. To keep ourselves from going crazy, we need to create a kind of recipe book for our code. And that recipe book is filled with functions.
A function is really just a block of code that you've given a name to. It's exactly like writing down the recipe for baking a cake. You write the instructions once, you name it bake_cake, and then anytime you need a cake, you just call that function by its name instead of rewriting all the steps. It is absolutely key to writing clean, efficient, and reusable code.
You know, a great recipe has to be easy to read and follow. And Python is actually famous for how readable its code is. But here's the thing. This isn't just a suggestion. Python actually enforces this clarity with a very unusual and pretty powerful rule.
This leads us to one of Python's most defining and sometimes strangest features. In this language, how your code looks is part of how it works. Now, a lot of other languages use curly braces or brackets to show which lines of code belong together in a block. Python? It uses whitespace, indentation. And that little indent isn't just for style points. It's a mandatory rule. If you get it wrong, your program just won't run, period.
And there are a few other tools that help with clarity too. Comments, which start with a hash symbol, are just notes for yourself or for other programmers. The computer completely ignores them. Then you have print function, which lets your program display messages on the screen, and input function, which lets it pause and actually ask the user for information. These are basically your channels of communication.
Okay, we've looked at all the individual pieces. Now, let's just take a step back and put them all together to see the full journey, from a single piece of data to a complete set of instructions.
So, we've really completed the full loop. We start with raw data, which we store in those named boxes called variables. Then, we use operators to perform actions on that data. After that, we build intelligence into our program using control flow to make decisions. And finally, we organize all of those instructions into reusable recipes called functions. That's really it. That's the core of what programming is.
You see, these concepts, variables, operators, control flow, functions, they aren't just a bunch of rules you have to memorize. They are the fundamental tools for solving problems and creating things in the digital world. You now have the map. So the only question left is, what are you going to build with it?